Hello everybody and welcome to your video notes on Learning Target 8.5 about circuit calculations. This video is going to be mostly about the basic level, which is just going to be about doing full calculations on series circuits. So here we go. Okay, so we are going to be doing, they're going to be called RIV tables, or that stands for resistance, current, and voltage. And here's what they're going to look like. So pause the video and you're going to want to jot this down in your notebook, or you can, just do that while you listen to me, either way. So we're going to use this table to calculate the resistance, current, and voltage for every piece of this circuit. So each resistor is going to get one row, and remember, we can treat light bulbs like they're resistors. So the 1 ohm resistor is going to get a row, the 2 ohm resistor is going to get a row, and then we'll put the totals down at the bottom. The battery is going to be V total, because that's going to be the total voltage supplied to the circuit. And then the last thing you need to know, not the last, but one thing you need to know is whenever you know two values in a row, you can find the third using Ohm's law. For example, if I knew the resistance of the resistor and I knew the current that was going through the resistor, I could calculate the voltage. Same thing for the totals. If I know the total resistance and I know the total voltage, which is going to be what we're going to do first, then we can find the total current. Here's another thing you need to know, is that in series, all of the current goes through all of the resistors. Remember, it's just like you're on the traffic, or if you're on the highway and these are toll booths. Everybody has to, there's no different pathway. Everybody has to go through each of these. So that makes the current slower, but also that means that all of the resistance just adds up. Okay, so I'm going to show you how to do this calculation now. Alright, so I kind of rearranged things here, but everything is still on the screen that needs to be here. Just as a reminder, we're doing 8.5 basic level, and we're doing RIV tables. So, one thing that you should absolutely write down, if you have not yet, write down all this stuff, but highlight this guy right here. Circle it, put stars around it. That's a terrible star. That's a better star. Still not great. Whatever. Put little fireworks coming out of it. A little smiley face next to it, because that is one thing you're going to need on your quiz. So, here we go. What's that little guy going to... Okay, I guess that guy's going to stay there. Alright, so let's just start by filling this in. I want to change my little drawing skills here. I could probably zoom on this just a little bit more. There we go. So each resistor gets one row. So I'm going to have 1 ohm there and 2 ohms there. So the total for circuit goes on the bottom row. Yep. And then the battery is V total. So this guy right here, 6 volts. That's going to go there. We know that the voltage is always going to be just given to us like that. Okay? So now we're going to use what's in red here to find the rest. So if I can find two values in a row, we can find the third using Ohm's law. Alright? So if I could, let's say, find the total resistance here, I could find the total current. And so the way that works is I would just add these up, because since it's series, I can just have 1 ohm plus 2 ohms, and hey, oh my gosh, my elementary math pays off. I know that is 3 ohms. Okay, so now since I know both of these, I can find the missing current using Ohm's law. That's what it says written in red right there. So let's change over to red just to match that. So now I'm going to find that by doing I equals V over R. And so that gets me 6 volts divided by 3 ohms. So that gets me 2 amps. Okay. Now, going back to the table, we need to fill in the full thing, so there has to be some way to do this. Well, if you look at this guy that I said, hey, you want to circle that star, that whatever, in series, all current through all resistors. So, that means that the current is the same for all resistors. So that means that then the 2 amps is true for all of them. Now this is only true for series. It's going to be different for parallel, but these are the rules for series. Okay. So now if that's true, then we can find out what the voltage is. Hey, look at that. Because now we have the 2 things, so we can find the third. So for the 1 ohm resistor, that's going to look like this. The equation ends up being V equals I times R. Once we rearrange, and I get 2 times 1, so that would be 2 volts. Okay, and then for the 2 ohm resistor, I end up with V equals I times R again, and I end up with 3 times 2, I'm getting that from right here, and that equals 6 volts. Oh, I did that wrong, didn't I? Back up, rewind. 2 and 2. I was looking down at my totals. Like, I thought we already got 6 volts. So, 2 times 2, so 2 ohms times 2 amps. That'll help me if I actually include my units. I end up with 4 volts. Okay? And then the last thing is this. You can always check your answer by adding the voltages together. This should equal the total voltage. See, I was already thinking ahead, and when I was going to get 6 as an answer, I knew that 2 plus 6 couldn't equal 6, so I was like, hey, what did I do wrong? But we know that 2 volts is 4 volts equals 6. Correct. Okay. All right, I'm going to have you try a couple problems on your own. Okay, so now you've got a circuit with 3 resistors in it, unlike the last one, which had 2. But the directions say complete the RIV table for this circuit. So before I have you just go off on your own, you're going to want to create the table first. So you're going to have 1 row for each of the resistors and then 1 row for the total. So you're going to get something that looks like this. Okay? And so go ahead and pause the video now and see if you can fill in the rest on your own. And don't forget about these rules. You should have them written down. Where's my mouse? Oh, there it is. You should have these all written down in your notebook. If you don't, make sure you write them down now, because that's going to be how you decide how to do your table. Okay, here comes the answers in just a little bit. Okay, and here is what I get for my answers. So the first thing that I started with was adding these three up, and I got 17 ohms. And remember, we can add these up because this is a series circuit, and you just find the total resistance just by adding them all together. And I got the 9 volts from over here. I know I'm really zoomed in, but on the picture it said that it was 9 volts. So I knew that that needed to go in there. And then, since I know those two things, I can always find the third. So then I did 9 volts divided by 17 ohms, and I got 0.529 amps. There's a few more decimals, but I think it's good to, 3 or 4 decimals if you got a small number like that. It's not a bad idea. And then, since we know that this is a series circuit, and again, super zoomed in, but series circuit, all the current goes through all resistors, which means that the current is the same for all resistors. So I wrote that out for everything. And then in order to find the voltage, I now know two things, the resistance and the current. So then I can find the third, which is the voltage. So I just have to multiply them together. I get 5.29, 5 times 0.529 equals 2.65. 2 times the current gives me 1.06. And then I did my double check. I got 5.29 plus 2.65 plus 1.06, and that got me my 9 volts, which is what I want. Now keep in mind, if I had gotten like 9.01 or 8.9, those are pretty close. We know that we rounded our numbers. I was actually pleasantly surprised to find that we ended up with 9 volts. So there we go. If you'd like to do another practice problem, I don't think that would be a bad idea. So I pulled this one in. So again, go ahead and pause the video if you want to do another practice problem, and I'll show you the answer here in just a moment. Alright, and here is what I get. So I started by doing the black stuff first. Let's get my highlighter. That's what I was doing. So, I put in my 12, 6, 12, 6. It's okay if you don't have them in the same order. And I added those together and I got 36 because it's series, and so I just add them together. And then the voltage was given to me, 6 volts, 6 volts. And then I did the purple next. I knew the two things in black, so I could find the third. So I did 6 volts divided by 36 ohms, and I got 0.1667, well, 1.6 rep per tan, but with a 6 repeating, but I just rounded that up there. And I got the same current for everything because this is a series circuit, so everything is the same for current. And then I used my two things that I knew for each resistor, the resistance and the current, multiplied those two together and got 2, 1, 2, 1 for each of the voltages. And then I did a nice little double check here, and I did 2 plus 1 plus 2 plus 1, and that gave me 6, and I got excited because that is correct. So that's all I got. Thanks for listening.